Hello YouTube, XDT here. Today we're solving Sync, a 50-point Linux machine on HackTheBox that involves HTTP request smuggling and retrieving secrets from Localstack. So let's have a look at the port scan results. We have 22 for SSH and 3000 and 5000, where we don't really know what it is yet. Scroll down a bit to the Nmap results. So 3000 is some kind of website. And here we can see it's actually Git, some website where you can manage your Git repositories. And on port 5000 we have Gunicon. So let's have a look at these websites. So here's our Git site. Can explore it here. Can see an organization, some users, but nothing really interesting because we can't log in, right? So let's look at port 5000. And here we seem to have some custom application. Let's make it a bit bigger. And there's a sign up button here, so let's register a user. Here we go. So this is some DevOps related page. Seems we can leave a comment here, which is then displayed, and we can also delete it. Okay. Other than that, there seems to be a notes page where we can store stuff and then view it. Okay. And we can also delete these nodes. What do we have on contact? Contact isn't linking to anywhere. Then we have a logout button. So this is basically it for the web page. See if there's anything interesting in Burp. And actually, one thing is kind of interesting here. It has this header here, which is telling us that HA proxy is used. Now, HA proxy is a load balancer. So basically, whenever you send a request, it decides to which backend server it gives it to. So you can have multiple backend servers, but just one frontend, and HA proxy is handling the load between them. So let's have a deeper look at this comment feature here. Let's send it to the repeater. There isn't actually too much interesting things going on here. We basically just post the message to the endpoint. But the suspicious thing is this HA proxy. Why would you have that on such a box if it wouldn't play an essential role? And this eventually will lead you to a blog post if you just look for vulnerabilities within HA proxy, which has this CVE from 2019, which describes that it's vulnerable to HTTP request smuggling. So let's go over this post really briefly. What happens in an HTTP request smuggling attack? Well, a frontend server wants to send several HTTP requests over the same backend connection. This is one of the reasons this attack in the end works. And this is done because of efficiency reasons. It's just much faster to send them over the same connection. And in order for this to work, the frontend and backend server need to agree on some kind of boundary between the requests, so they both have the same understanding of where a request starts and where it ends. So in order to define this boundary between the requests, the HTTP specification has two ways, the content length header and the transfer encoding header, which kind of do the same thing, but in a different way. So content length is just saying how many bytes does the body of the message have, which is 11 in this case, while transfer encoding does basically the same, but the format is a bit different. Here we see transfer encoding chunked, then it's telling us the size here, which is 11 as well. Here we have our content, which is the same as above, and it's basically at the end, there's 1 0 chunk, so there's always a 0 at the end. And the frontend and backend may be using different ones of these. So one might be using content length and one might be using transfer encoding, and this is where the problem starts. So the first vulnerability, which is kind of similar to what we have on the box, is this content length transfer encoding vulnerability. And you can see it very well in this example here. Basically here, they define both headers, content length and transfer encoding, in the same message, which usually doesn't occur together. So one of them might be reading the content length, like the frontend server, which is 13, which includes this word smuggled here at the end as well. But if the backend server sees the same request, it might interpret it only the transfer encoding header, and this terminates at the 0 here, because that's basically what in transfer encoding tells the request is done, right? So this word smuggled here is still on the socket, it's still on the network connection, but it's not processed by the backend server. So whenever the next HTTP request occurs, this smuggled word is still in this buffer. So it will be prepended to whatever next request occurs. So back to HA proxy and the bug we have in this specific case. Here we specify content length and transfer coding at the same time, which you normally wouldn't do, right? But it's processing it correctly. It's basically ignoring the content length and just using the transfer encoding chunk here and not sending this X here at the bottom, which would only be sent if content length would be used. But they found there's a specific case where this is not true. If they put a 0B, which is a vertical tab, in front of the chunk here, it will actually transfer the whole thing. So it's using the content length instead. And the interesting thing is that it's not only using the content length, it only keeps the transfer encoding header here sort of intact. So if it gets to the backend, there's still the transfer encoding chunked header, and it might use that one. So let's look at the final example. We sent a request to HA proxy, which has content length and transfer encoding chunked at the same time with this 0B here in front. And first of all, content length 4 means that the last character won't be forwarded because it's this 1 plus new line, Z plus new line. So the backend just sees 1Z here at the end. But the big issue is basically that now the backend gets this request and the transfer encoding chunked header is still here. And if the backend decides to interpret it chunked instead of content length, it will basically see that there's one chunk here with one character. This is okay, but now it waits for the terminating 0, which is never being sent. So now this is still somewhat in the pipeline, and the request is timing out, waiting for the rest of this request, right? So let's see how we can exploit this in this particular web app. First of all, we need to add the transfer encoding header here, which is chunked. And then remember, we have to have this 0B here in front. First of all, let me activate these line breaks here. Now you can see it a bit better. And then we just write %0B and hit Control-Shift-U to encode it. And now we have the special character in place. And now we don't want to send this message here. We are going to send the 0. And I'm going to explain in a second why. So now what have we done? Well, the front end will see this content length here, which will be updated when we send our request. This will just be the automated content length. So everything I've marked right now. So the complete body. And this is being sent to HA proxy, which will use the content length. So it will send on the whole thing. And in the backend, there will be still a transfer encoding chunked header. So the backend will use the chunked encoding. So what will the backend do? Well, it sees this 0 here and carriage return line feed, carriage return line feed, and it will basically terminate the request at this point because it doesn't see this rest here as being part of the same request. So this part I just marked is still kind of stuck in the pipeline, and whenever the next request comes, this whole thing will be prepended to the request. So imagine the next request looks similar to this. It would be pasted here. So what this means in the end is that there will be a comment posted that contains the whole request that's coming afterwards. I know it's a bit complicated to understand. I had to read it a few times as well. So let's send that for now. Seems to have worked. And now we've basically poisoned this pipeline, and the next request should be included inside the message of the post. Let's refresh that. And here we go. What happens here is that the next request is actually made by some code in the backend or a bot or something like that. So this was not our request. We made this one request here, and then we poisoned the pipeline, and the next request was included here in the message. And this is actually the admin doing some node delete stuff here. And because we poisoned the pipeline, we can get his session cookie that way. So let's use that cookie. Just going to edit this here. Now let's refresh the page. And we are indeed admin, as we can see on the logout button here. So this worked. Let's see if there are any interesting notes here. And there are indeed a couple of interesting ones. There's a login for Chef, although I didn't see any Chef. A dev node URL. Code.sync would be the Git we saw, right? And also Nagios. I didn't see that either. So let's copy these. And let's try to log into the Git with these credentials here. This looks good. We can log into the application. And there are a couple of repositories here, so let's look around a bit. There's log management, the serverless plugin, whatever this is, and some Kinesis Elasticsearch. I don't know. Let's look here. There's also key management, which isn't listed here for whatever reason. Let's have a look at that one. Let's look at the commits. And there are a couple commits here from a user called Marcus. Let's look around a bit. No SSH, maybe something with key. Yeah, and eventually you will find this commit here, which is an SSH private key. And this is the one we can use to connect to the box. So you have to look around a bit to find that, obviously. So let's save that, add a new line at the end. And we are in, and we can read the user flag. So for the next part, we have to go back to the Git repository because there's more stuff here. There is this log management repository, and there's this create logs.php file. And we can see that there are credentials here, but they are removed for some reason. And a good thing you can always do is see if in the earlier commit, maybe they are still here. This happens a lot. So let's see. Maybe this one. Yeah, here we go. We got a key and a secret. And this will allow us to access AWS. The box doesn't have internet. So the way they've done this is a Localstack installation, which basically mimics AWS services. So let's see if the AWS CLI is installed here. And this looks good. Now we should be able to do AWS configure and give it this key ID, the secret, some region, don't think it matters. And now we should be able to use the CLI. Let's see. Maybe we do key management service list keys. This doesn't work. And the reason for that is that it tries to connect to AWS. So we have to tell it to try to connect to the local server instead. And we can do that by giving it an endpoint URL here. Just localhost 5466. And now we see a list of keys here that the user might or might not have access to. And now we have to find something useful for us, right? Maybe the repository can somehow help us. There's maybe something in here. But there really is just this create logs PHP file here, right? And now basically we have to find out what our key is allowed to do. And I know there are a couple of tools to do it versus the real AWS environment, but I'm not sure if they work on this local installation. So if you know a tool, let me know. I think when I did the box, I mostly did it manually and just tried things out, right? And one thing that works is we can query the secrets manager and list secrets. So what I did before is I listed keys, and now I want to list secrets. And here we can see that some secrets are indeed stored and we do have access to them. Let me just copy the command here. There's a Jenkins login, there's a sync panel, and there's Jira support. And in order to get a specific one of these secrets, we have to use a specific syntax. I'm going to copy that. Same as before, we give it the endpoint. We tell it to communicate with the secrets manager, and then we want get secret value. And we have to give it a secret ID, which we can copy as just this long thing here, right? And we have to try all of these, but I know it's the Jira one, so I'm just going to use that one. And here we go. We get a secret string, which has credentials. So let's see, this user, David, is also user on the box, so we should be able to SU to him if the password is correct. And this indeed works. We're David. Check ID, there aren't any special groups here, but there's a projects folder. Let's have a look here. Prod deployment. And there's a servers.enc file, and usually these are encrypted files, right? Just use XXD here. And yeah, it looks pretty much like gibberish. It's safe to say it's encrypted data. So how can we decrypt this? Well, we don't really know which software, whatever, was used to encrypt it, but since we are still in this AWS environment, it's probably safe to say that will be some AWS thing to decrypt it. And if you Google for that, you will find that there's AWS KMS Decrypt as a command. And we have to give it a couple of arguments, like the ciphertext file and the endpoint and so on. So let me just copy that. We do AWS KMS Decrypt. We give it the ciphertext blob, which is this servers.enc file. And of course, we give it the endpoint URL again. Let's see if it works. Now it's complaining that we are missing a region. So just try that again. Okay, now it's done it. If we get an access denied exception, the ciphertext refers to a custom master key that does not exist in this region, or you're not allowed to access it. But remember, one of the first things we did here is list keys. And there are a list of keys here. We can basically try all of them to decrypt this. You can script it or just do it by hand. So basically, we would do the same command we did before. We say key ID, and then we just give it these keys, right? Just paste a random one here. And there would be errors like this one that's saying us that the key is disabled. And you try that for all of them. And it's telling us that it's disabled for most of them, except for 2 keys. And only one of them will give a cipher error. And this is how you can basically narrow down which key to use here. I'm not going to do it for every key here because it takes time, but yeah, you get the process. And if you're done, narrowed it down to the cipher error, you can do AWS KMS Decrypt key with the key you found. And then we can see which encryption algorithms are actually supported by this key. And the decrypt command needs to be supplied the correct algorithm. So we do that again, this time just with the correct key here and the encryption algorithm, which is this one we copied from here. And now we should be able to decrypt the file. This is the base64 encoded file, so let's decode that. And it's gzip compressed, so undo that. And here we get 2 files, which one of them is servers.yaml. And we get another pair of credentials. And it turns out that these are valid for the root user. So we can SU to root, give it this password, and we're root and can read the final flag. So that's it. I think it was a pretty cool box. Let me know what you think in the comments. If you liked the video, click the like button, subscribe, and see you next week.